Welcome back to Object-Oriented Programming 1. We are now continuing with the second part of today's double lecture. So we have today introduced classes, we got to know methods, member variables, getters, setters, the constructor, the destructor. We will use all of these principles also now in the second part of this double lecture. But first, let's have a short recap on what we've learned in the past hour. And we will go through this example in detail. So we will have a look at every single component, add some explanations on that, and also thank you for adding and posting all your questions in the Q&A. We will now try to include them here in this example as good as possible. All right, so we have introduced the concepts of classes, which are the central component in object-oriented programming. We have this class definition here. So we have a class named bed. And we can see this class can have some contents. For example, we have class members. So these are just variables that are used in the class. We can do whatever we want with them in the class. And usually they have some access specifier. So they are either private or public. They should be private most of the time. So we have the access specifier. We have the private access specifier, which means we can only access these objects, so these member variables, but also methods within the class. But there's also the access specifier called public, and another one. We will learn about that next week. And with the public access specifier, we can also access the elements. So for example, member variables that are declared as public, but also, and most of the time, these are methods outside of the class. So we can access the methods in our main function, in any other function. We also learned about the constructor, which is used to create an object, which is used to create an instance of a class. For example, here we have a constructor without any arguments, and we call this constructor the default constructor. So no arguments, nothing happens, in this case, in the body of the constructor. The syntax of the constructor is quite easy. It's just the class name followed by these parentheses here. No arguments, so very simple. We can also have multiple additional constructors. In this case, we have a constructor with one argument. So we pass an age, and this age is then set to our private member variable age in the class. So we create an object, pass an integer value, and this value is then set to the age member variable of our class object. Of course, we can have multiple constructors, but it's important that they have different parameters. It's the same principle as function overloading. If we have multiple functions, or in this case constructors with the same name, we have to distinguish between the different number of parameters and also the type, so the data type of the parameters. So that's great. We can now construct or create objects, and I think we can also discuss our first question here. That we got.
One of the first questions was if you want to check the values of the arguments in a constructor, can I first make the check and then use the initialization list? So basically, can I execute code in the code block and then the initialization list is executed?
That's actually a very good question. And let's take a look at this constructor here. So we have the initialization list here. We set the age that is passed in this constructor to the member variable age, and we have an empty body of this constructor. So now the question is, can I do some checks in the body of the constructor here and still use the initialization list? And unfortunately, we cannot do this because the initialization list here is always executed before the body of the constructor is executed. So we cannot do any checks here in this part when using an initialization list.
So you can use both, but you cannot write something in the body. Let's say only set the age if the age is below 20, and only then the initialization list should be executed, because the initialization list is executed first before the body. Yeah. So you can have code in the body, but the initialization list is always executed first.
Yeah. So if you have a check regarding the age in the body, of course it works, but it will not affect that this part here is executed before. So we set the age before in this case.
Yeah. Okay. Let's move on with the next.
The next element that we have discussed is the destructor. We will talk about the destructor in detail now, the upcoming 1 hour. And yeah, it's used when an object is destroyed, or it's called when an object is destroyed. We will see some use cases in a few minutes. And we also have methods, or in this case, specific type of methods. In this case, we have the getter method for getting the value of a member variable, and also the setter. So the setter method, which is used to set a value to a member variable without actually using the member variable outside of the class. As we've heard before, if we want to have some checks here, for example, we only allow the age to be less than 20, we can do this perfectly fine in a setter method, but we couldn't do this if we simply assign the value using the member variable. That's why.
And there's one question to that. What happens now if I call set age with 60? Will that be an error, or what is then the behavior?
It's a very good question. So if we pass set age and the value 60 to the setter method, let's go through it. Age is obviously more than 20. This means this part here is never executed, so the member variable age remains unchanged.
Yeah.
There's no error, nothing happens.
Yeah. So it depends on your implementation. Of course, you can output here something, please enter an age below 20, otherwise it's not set, or you can just ignore it. It depends on your implementation. But there is no error or whatever.
No.
So
it works, but of course it would be more beautiful if you have a error message or maybe even an exception, but...
And then we have 3 more interesting questions which are picked, which are a bit more basic, let's say. What is scope for? Scope is not really a thing we want to use. It's more like a rule of programming. It's kind of defined what scope is, and you have to follow it, and that's why you have to know when an object dies. That's basically scope. Another question was, why do we need to use std double column all the time? And also, do we need to use it in your assignments? Yes. This std double column here, for example, in the string, just means that's in the standard library, and there is defined a string type. So it's basically the data type in this case. And every time you use something from the standard library, then you need to write this std double column, which is a bit annoying.
It is a bit annoying, but also very helpful if we, for example, have naming conflicts, naming clashes. And we also call this here the scope resolution operator.
And I have to correct myself. I said double column. It's just double column because that's the double column. Yeah, I always get confused about that.
Let's just call it scope resolution operator, which means that inside of this namespace here, std, we will have an object or a data type which is called string, and by specifying the namespace together with the element here, string, we for sure know that this element is meant and should be used.
Yeah, and I have to admit it's a bit annoying in C++. That's a disadvantage. So you can, I think, did you talk about using last time?
We introduced using. We also mentioned that you should avoid
using std in general, but in this case you can write using std string, And then you only need to write string and omit this std double column. That would work. The same with std cout, for example.
Yeah.
Okay, and one more question. Why do you not use brace initialization? So there are two reasons for that. I personally prefer the other way because I'm used to C more than C++, and I use the C initialization more than brace initialization. And also for demonstration, I think it's more familiar to you, but you can do it however you want. Okay, then I think we can move on. The other one was not really meaningful questions, maybe just comments or, yeah.
All right, then let's start with the first concept of the second part of today's lecture, which is static. Static is, especially in object-oriented programming, very useful because, let's just see it, all the static members of a class, so for all objects as well, they have the same value. So whenever you have a static variable, this static variable will have the same value independent if it's the first object or another object or any object of this class. So it's always the same, doesn't matter which object you're using and, for example, trying to access this variable. Quite useful, I would say, also heavily used in C++. And you just need the keyword static here in front of this member variable. Here we have it as a public member variable. And what's important here is that you first declare it here inside of the class. And after that, you have to declare, and in this case also initialize it again outside of this class. So, yeah, we can now use this variable, for example, by just using the class name and then the scope resolution operator, and then accessing, in this case, printing it, it will work. It will also work, for example, if we create objects and then try to access this. Let's take a look. If we now initialize the static member, we always have to do this outside of the class, otherwise it would not work. We will get a compiler error, and this is also the case because here, whenever we declare it inside of this variable, or inside of this class, the variable actually doesn't exist. So it's more like a placeholder that somewhen the variable will be created in the memory, and this actually happens here in this line of code.
So outside of classes, outside of functions
as well, yeah.
It's basically a global variable.
It actually is a global variable.
So
and
in this case, you're allowed to use global variables.
Yeah, so accessing it is simply done by using the namespace. In this case, it's the class name, and then using the scope resolution operator. So yeah, quite useful. It works. It also works if we now create multiple objects or instances of this class. So we have the same class and this static variable here. And in our main function, we now create one object called Skoda, one object called Seat. And if we now print this number of wheels static variable, we will get the same results for both of them. So it doesn't matter if we use, I think it's pronounced Skoda. But
Skoda, yeah.
Skoda, yeah. Doesn't matter if we use Skoda or Seat. It will always be the same since it's a static variable, and we know that static variables always have the same value for all objects of a class.
One comment to this.
Yeah.
If we don't write static here, so here in this case, yeah? Just to sum it up a bit, if we don't write static, the Skoda and the Seat can have a different number of wheels, so they can hold different values. But if you write static, they always have the same number. So when I change it for Skoda, it will also change automatically for Seat.
Yeah. So if we change the value to 6, then both Skoda and Seat and all the other objects that we have created from our class car will have the same number of wheels. But we cannot only have static variables, we can also have static methods. And similar to static variables, again, the static methods are the same for all objects. So again, it doesn't matter which object is calling this method, or actually that we are most of the time using the class name, it will always have the same behavior. So similar to the static variables, we can again call a static method using the namespace, or in this case the class, followed by the scope resolution operator, and then the name of this static method. And similar to the static variables, we can again use the object name dot static method name. We'll also see that then later, but usually we just use the class name, scope resolution operator, and
because now I know that this is a static method in this case. Otherwise, it could also be just a normal method. But if I call it like this, so car double column, then it's obvious that it's a static method.
Yeah, we can be sure that this method was declared as static. But now it gets interesting. So we have this static method in our class. It's called display message, and we want to print the number of people here in our static method. However, this will not work because we have a static method, and inside of the static method, we are using a non-static member variable, in this case, people. And whenever we have a static method, we cannot use any non-static member inside of this static method. It also wouldn't make sense, actually.
No, because the method doesn't know the value of which object should be taken here. So maybe there are 5 different car objects exist, and they have a different number here stored. So what should it take? Makes no sense. Yeah.
And especially if we just call it using the class name, there is actually not a number of people that is assigned to the variable here. So we are not allowed to use any non-static member inside of a static method. However, static methods are quite useful, especially when it's a general behavior of all objects of a classes. So whenever we have something that is the same for all objects of classes, we can use a static method because this is independent of all objects and will always do the same. Doesn't matter if it's called by an object or by the class name. Any questions to static so far? Yes?
Can you use it as a signature for objects so you can track how many objects you need to generate?
That's a very good question and a very good use case actually for static variables. For example, counting something independently of an object. So for all objects of a class, also for counting the number of objects of a class, it's a really good use case for this. Yeah. Yes?
It's important in which class we write this static method. Like we have class car and we have class human. It's important the static void display message we write in car for it.
So the question is, if we, for example, have another class called human or whatever, and does it matter if the static method is in the car function, in the car class, or in the human class? It depends on what you want to do with the static method. So it can only belong to one class, and I don't know if there is any general behavior between human and car, but it should belong either to car or to human, so it's not possible to have one static method that is also used in another class. So it depends on what you want to do with the static method, and it can only be in one of these classes.
Yeah.
Yes? Set, if we can call static variables. Yeah, so if I got it right, the question is if I can modify static variables also inside of the main function. Yeah. I'm not sure if this is also, I think this is part of the quiz then.
I'm not sure,
so I don't want to spoil too much here, but yeah, you can do this, and you most of the time you do this.
Yeah, it's part of the quiz on the next page. Yeah.
That's bad. Any other questions? Yes. Why would I use a static method within a class instead of a global function? Let's call it like that. There might be some behavior that should only be accessible by objects or the class itself, but not by anyone else, for example. So you want to restrict the use of the static method by calling the class name or the objects actually, instead of allowing anyone to use this method. So it's, again, it depends on the use case, if you want to allow anyone to use this function or just objects of this class by calling this static method.
But I think it's a very good question, but maybe on a deeper level, because when we do object-oriented programming, we do not use functions anymore that are outside of classes. We use the main as an entry point, but nearly every other logic is directly inside a class. So you will get used to it, and it takes a bit of practice, of course, but you use the main as entry points, then you create your few classes, whatever it is, and then you are going inside classes, and then you execute the classes. So in object-oriented programming, it's very, very popular to only work inside of classes and not really in functions outside of classes anymore.
Yeah, it's way more structured, way more organized.
Yeah.
For example, I've used a lot of classes that only have static methods, for example, or static variables and methods, but still they're inside of a class because it's more structured.
Okay, I think we can move on to the quiz. I think it's another quiz to log in, right? Or is it the same? I'm not sure, so I think you have to check. But I think it's a different, because it's a different presentation. I think it's also a different QR code to scan. Yeah, it's different, yeah. So you have to log in again.
So now we have this example trying to modify the value number of wheels inside the main function using two objects that we have created. Now we want to print the number of wheels of our Ferrari. Is there a Ferrari with 6 wheels?
Not to my knowledge, I don't know. I don't think Ferrari make trucks. I'm not sure.
I'm also not sure.
No, I think they all have 4 wheels.
Okay, a few more seconds. And yeah, great. So actually not very realistic, but the Ferrari that we printed here in this line has 6 wheels. Why is this the case? Any idea? Yes. Exactly, yeah. So we first modify the static variable here in this line. We assign 4 to the static variable number of wheels using the Ferrari object. And here in this line, we are using the Mercedes object, again modifying the number of wheels and assigning 6 to this static variable. But as we've mentioned now multiple times, whenever we have a static variable and we modify this variable, this applies to all objects and the whole class because the static variable only has one value for all objects of this class. So modifying this value here will also modify the value for the Ferrari, actually not really modifying it here, but there's just one value. And since this is the last change here, Ferrari will also have 6 wheels, or actually all objects will have 6 wheels here. We could also use the class name car here, and using the scope resolution operator, this would lead to the same result. Okay, now we come to the conclusion of static. So we have static member variables or attributes and also static methods. The value for all the static members is the same for all objects. We can access static member variables using class name, scope resolution operator, and then the static member variable. Or we can also do it using the name of an object, dot member. The same applies to static methods. Again, we can use the class and the method name, but also it should be method here as well. It should be object.method, of course. And what's important when using static methods is that we cannot access any attributes of objects, so any non-static members, but only static attributes can be accessed and used in a static method.
Okay, so we already spent half an hour again on static and on the recap. So there's another keyword which is const, and const can confuses you. And someone said C++ is such a straightforward and easy to grasp language because you can do things like that. And that's actually a valid line of code. In C++, const int pointer, const get age, const int pointer, const. Yeah. We will now learn what this is and what this means. Oh, I made a mistake here. Okay. So const in general means I make a promise I will not change this in the future. So when I create here my variable const, I cannot modify it. I cannot add a new value or whatever. I will get a compiler error here. The same if I am inside a function or a method and I declare here a const parameter, this means that this variable cannot be changed here. So in this case, I also get a compiler error. So const just means it cannot be changed, it should not be changed, otherwise there is a compiler error. So far so easy, but when it comes to pointers, it's getting very, very confusing. Let's say we create here a const int age5, so this age cannot be modified. And I also create here an ID, which is not const. Then when I want to create a pointer to this age, so taking the address of the age, this needs to be const here, and this const here means that the value of my pointer, so the age, cannot be modified. So here means the content of the pointer cannot be modified. So this won't work. Dereferencing and adding or overwriting the value will not work, but it will work to reassign the pointer. So not changing the values, but changing the pointer works. In other words, or in the other direction, if I have again the const int age and this int id 20, and I write this const on this side of the pointer, so not the const int pointer, but an int pointer const. This means the opposite. This means that the pointer is not modifiable, so I can change the value of age, but I cannot change the pointer itself. Pretty confusing, I have to admit. Yeah. And of course you can combine it. You can say I have a const int pointer const pointer, and which has the address of ID, and then I cannot modify the value, and I can also not modify the pointer. So it's just the combination of these both. So now we already know what this const is, this const is, this const is, and this const is, because this is the return value here, and this is just the first argument. But the question now is what this const here means. And this const here means that the body of my method, in this case, will not modify the class. So the class has attributes like the age, and when I write const here between my function declaration or method declaration and the body, this means that this method will not modify this current pet object. So in this case, it will not modify the age or any other attributes inside. Getters are, usually should be const, because you just get something and you don't modify something. Setters, on the other hand, their purpose is to modify the object, because setting something, then const would not make sense here. So this is basically a method of a class that takes a pointer which value and pointer is not modifiable. So this one here. Returns a pointer which value and pointer is not modifiable, and do not modify the class itself, which is this one. Just for demonstration, of course you don't have to, or maybe there is no real use case to write a function like that, but it is, from a compiler perspective, correct to write it like this. But yeah, I just want to show you that there are different ways to use this const keyword in C++, and we need this now for the next topics, but maybe just a short question if there are any questions, or if there is anybody who understood const.
A lot of confusion.
Bottom line, const just means you can modify something, yeah. That's it. Okay, if there are no questions, that was fast.
Yeah.
Let's
Faster than expected.
move on to the more interesting part, because now we talking about copy constructor. It's a specific type of constructor.
And I would say let's start with a formal definition of the copy constructor. So we all already know the constructor, which is used to create objects of a class. And now a copy constructor is a special constructor which can be called with an argument of the same class type and then copies the content of the argument without mutating the argument. So what does this mean? So we have a constructor. The single argument that we pass to this constructor is an object of the same class type as the constructor in this class, and we then copy the content of this argument, so the object of the class, but without changing and modifying anything of the argument, so of the object of the class that is passed to the copy constructor.
Let's see an example because it's confusing.
It is confusing. I think this example here will show what the copy constructor does and how it is used. So we know these constructors here. We have a constructor without any arguments. We have this constructor with arguments for the name and for the superpower. And then there's this, I would say, weird-looking constructor which expects the superhero as an argument. But that's actually what the definition on the last slide said. So we pass an argument of the same class type, so superhero here, and then we copy all the contents of this argument, so of the superhero that was passed, to our new object. So again, using just the initialization list, but without modifying anything of the past argument. And this is basically what a copy constructor does and how it looks like. Important here is that it has to follow this signature. So yeah, we know the constructor, how it should look like. And then it has to be a const superhero or class reference. So that's very important. Whenever you write a copy constructor, it has to follow this specification, that it must be a const class, whatever, reference that is passed to this copy constructor. Otherwise, it will not be a copy constructor and will not work.
And you see here also that we are slowly introducing a bit more and more into classes. So in the middle constructor, we now also have const std string references of the name and const std string reference of the superpower. So it will not always remain very, very easily to just have one integer. In this case, we are passing two strings and we define it const, which means that this name and the superpower will not be changed in this constructor, which makes sense because I want to create in my main function, for example, a superhero, and I don't want to the constructor modify the name and the superpower I give a handover. Yeah. So const is a good thing here to prevent the function doing things we don't want to.
Unintended behavior.
Yeah.
So it's very useful to make sure that only things happen that you want to happen.
How can we call now this copy constructor?
Yeah, we will see how we can call this copy constructor, how it is used and called. For example, we first create an object superhero hero1 here. We know that we are using the constructor for or passing the name and the superpower. So this is what we already know, just a simple constructor. But yeah, here the second line is very interesting because we would assume that hero1 is assigned to hero2. It's again a new object that is assigned or created here. But when using this assignment and in the same line or in the same expression, creating a new object here, then the copy constructor gets called. So it's not hero2, then parenthesis, and hero1 in this case. We'll see that in the next slides. But it's just hero2, and hero1 is assigned to hero2. And this line here calls this copy constructor. So it's not that obvious in the first moment, but this assignment here, when initializing the superhero object, will call the copy constructor. And hero1 is passed as the argument, and all the contents, all the members listed here in the initialization list will be copied to hero2.
And this, I think, is the slide now where it's getting confusing. And for all the upcoming slides, it's getting harder and harder. So I know it's late in the day, but you just have to know when a copy constructor is called. This is one of the cases. There are even more cases which make no sense in the first thought, but you just, I think you were getting used to it, but copy constructors are tricky.
Yeah.
Very, very tricky. This is one use case where a copy constructor is called. There are other ones.
There are multiple ways to call or how a copy constructor is called. So we know when a new object is created and initialized, and we assign an already existing object to this newly created object, this will call the copy constructor. But also when we, for example, call any function, any method, and we pass this object here, hero1, as a value, so not passing it as a reference, but the actual value of this object, this will also call the copy constructor. Because when we pass this object to this function, and this function will then work with this object, what in reality happens is that when we pass this, a copy of this object is created, and since a copy is created, also the copy constructor is called. So hero1 here will be copied to the function or the method print superhero, and these are now two different objects. So hero1, where it is called, is not the same as hero1 in the print superhero function or method. So this is the second way how the copy constructor is called. And also, again, not very obvious, but you will definitely get used to it. Whenever we have a return statement of the same type, so in this case again the superhero, and any function, any method will return a superhero. If we do not specify anything special like a reference, for example, this will also call the copy constructor, because we return a variable from a function, from a method, to any other function or method that called this function, and a copy is created and passed back to the function or method that called this function.
If you have problems, so if you have problems with objects that do not take the values you want, this slide is the one you should have a look again, because especially the second and third, but also the first one, are not so obvious that a copy constructor is called, but it makes sense. So maybe we move to the next slide, and I have a comment there. So there are three different ways to call a copy constructor. The first one is when we create. So the first one is not the copy constructor, the first one is here. When we create this time class or time class object, we call the normal constructor. So this is just the normal constructor, which is here. And then we have here three different ways to call the copy constructor, which again, not really makes sense. This one makes sense, to be honest. Yeah. This means we're creating a T2 object of the time. We're handing over a time object, and then this means we're creating an object and we're calling this copy constructor here. This makes sense.
Yeah, it also matches the signature of the copy constructor. So
This is the case we had previously. Also, this assignment implicitly calls the copy constructor. Not that obvious, but you have to just know it. This here calls this copy constructor here, so this also works. And this is maybe the least obvious one. You're calling a method, a function, you hand over an object, and this object, this T2 here, gets copied into the sync time. So this T2 here and the one who's taken here in this function or this method is a copy. Yeah, it's not the same. There is one thing to solve it. Did we mention it, or is it in the quiz?
I don't know if it's in the quiz. Could be.
Could be, okay. Then we leave it for the quiz. But the behavior here is really that we call this sync time function or method. Then first the copy constructor is called, and then with a copy of it, the sync time method is called. It makes sense if you think of this T1 or this T2 here is just an integer. If it's an integer, let's say 5, yeah, and we call a method, then also this 5 value, this integer, is just gets copied into the method, and we are working here with the copy of it. That's why we're using call by reference, so handing over the address or handing over references to have the actual value. And the same works here for non-primitive data types, for objects or whatever. Yeah, and I think it is really for the question from the next slide.
I think we also missed the last line here. So just assigning one object to an already existing object, this will not cause or will not call the copy constructor, but we'll also see that, I think, after the Easter break.
Yeah, it will take a bit of time, to be honest, because it's a completely different topic.
Yeah. So assigning one object to another object for integer values, it's trivial, I would say, but for objects, it can become a bit more complex. All right, then let's take a look here at this quiz, and we want to find out which of these copy constructors is the correct one for the class pet. Yeah, let's wait a few more seconds.
Okay, the results look pretty promising. I think we made our point clear.
Yeah, nice. So there's only one signature that is or reflects a correct copy constructor, and this has to include this const keyword here before the data type, and we also have to have the ampersand, so the reference here in this argument list for the argument that is passed, which is another object of the same class.
And now you might see that references are the key to avoid the copy constructor. It's also used in the copy constructor, but when we go back here to this one, how could we solve it to not make a copy in this line of code here? So here should not happen a copy, so calling the copy constructor. How can we fix it that not a copy is created or not the copy constructor is called? It's a similar concept, and with the copy constructor, I think it's always the same answer. Any ideas?
So we
Yes. Yes, taking a reference as parameter. So in the sync time, here we need a reference, and then it's not a copy, it's a reference or call by reference again, and then we are modifying the actual value. It's pretty similar to the thing we had today in the first recap with vectors and the auto, where we modified a copy of the vector, of the elements in the vector. This case, again, using references helps you a lot when you don't want these copies. Yeah. Yeah.
So the question is if there's a default copy constructor.
Yeah.
No, there is actually not a default copy constructor, so you have to specify this all the time whenever you want to have a copy constructor. So you have to explicitly write the constructor followed by const, class name, reference, and argument name, and then
there is one.
There's one?
Yeah, there is one. Yeah, I just got confused too.
Yeah.
There
Okay,
is
okay.
one. There is a copy constructor.
Oh, that's nice.
If you don't define it, the compiler automatically supplies a copy constructor, but it only works for the basic data types. So, for example, copying the integers and so on.
The primitive data types.
The primitive
Okay.
data types. Yeah,
Okay.
yeah.
So whenever we define object by our own, it will not work.
No.
Okay.
But yeah, there is a default version, yeah.
Okay. Let's
But as always, I would highly recommend to implement it on your own because you have more control of it. And you don't know, so otherwise you don't know what happens under the hood when it's the default copy constructor. And as soon as you implement it on your own, you have more control what happens inside.
Okay, the next topic now, dynamic memory in C++. Flashbacks to C.
There is
introduction.
also this concept in C++, unfortunately, yeah.
And it's probably not the last time that you will see malloc and free in your study program, most likely. However, in this course, so
It's the last time.
in C++, in object-oriented programming, we will have this now, hopefully the last time. So we are all familiar with the concept of malloc and free. We are using malloc to allocate memory on the heap, and we're using free to free this memory that we have previously allocated. And we also need something similar in C++, but we don't call it malloc and free anymore, but we will call it new and delete. Also looks more beautiful in my opinion.
Yeah, and it is, I think, a bit easier to handle compared to the C version.
It is, yes, and basically the same thing as malloc happens in this line. So instead of calling malloc, we just say new and then the name of the class, followed by the arguments passed to the constructor. And this part here will allocate memory on the heap for our object, and it will return a pointer which is then stored in this variable here. So it's a time pointer, and what is returned by this new time call here is stored here. And of course, whenever we allocate memory on the heap, we also have to free this memory, but we are not using free anymore. We are now just using this delete keyword, and this has the same functionality as the free function in C. So I would say a bit easier, more beautiful.
I think it's easier because in malloc we always allocated bytes.
Yeah.
So we had to define like 3 times the size of whatever object or the size of this object. In this case here with new, we can directly create the object using the constructor, and with this new keyword it is just constructed or created on the heap. So remember what's the difference between this line here, so the new time, and when I just create the time on as local variable. The difference here is that this with new time here is on the heap, and so I have to delete it. And when I have it as a local variable, it is deleted as soon as it gets out of scope here.
Yep. Okay, now the question is, of course, it can happen, same as in C. What if there's no more memory that we can allocate using new, for example? New will not return null. So in C, when we use malloc, malloc would return null if there is no more memory available, or simply the memory allocation was not successful. But new will return an exception instead. So yeah, there are exceptions in C++. We will talk about exceptions again, I think, after the Easter break. And they are way more convenient than just having a null check, doing something, then freeing this pointer. So exceptions would be a lot more helpful.
So,
and
good for today is no more null checks.
Yeah.
We don't need it anymore in C++. We need the concept of exceptions, but that's a whole new topic we will discuss in a few weeks. And until then, you don't need to do any null checks. That's cool.
Yeah. So there's also a huge benefit of new and delete. We can also do something similar for arrays, but instead of using malloc here again with the number of elements, so 5 times the size of an int, we just call new int and then the number of elements. So we don't need the bytes anymore, we just need the number of elements. But when we have arrays, we always have to use these brackets here, and we also have to use them when we delete the array. So we have to use it for new, but also for the delete statement here. Otherwise, not the whole array would be deleted, but only, I think, one element.
Yeah. But that's for arrays, and usually we don't use arrays anymore. There is a more convenient way. I think you talked about vectors already. Yeah, sure. We will come to that in 3 slides, I think. The first real example how to use dynamic memory together with classes, together with all the things we've learned now, also constructors, destructors. But first we have a quiz.
Yeah, and here we want to know which constructor is called in which line. So, is it a default constructor? Is it just any constructor? Is it the copy constructor? Does it even work? We will see. yeah, we have 3 pet objects.
You have interesting pets. A goat, a horse, and a donkey all at home. Yeah. Cool. Okay, let's have a look.
Let's see. And yeah, most of you got it right. That's again great. So let's take a brief look what happens here. So yeah, this is just a usual way to create an object using a specific constructor that expects one argument, a string. So here just a usual constructor is called. Now in the second line, I think we have discussed it extensively today.
Yeah.
When we create an object and we initialize it in the same statement, assigning one object to this newly created object, then the copy constructor is called. So line 2 uses the copy constructor, and line 3, yeah, it's just a brace initialization, another way to create an object, but here again the usual constructor is called, but not the copy constructor. Great.
Okay, we already talked about the destructor, and now we have the first use case for the destructor. We had this before, so destroying an object means we're calling the destructor, a destructor is called, and it's always the destructor is called as soon as it goes out of scope, when it is on the stack. Of course, if it's on the heap, then it's again different. Question for you, when is the destructor called when the object is on the heap? Yes? When it gets deleted, yeah. So it's not when it's out of scope, when it gets deleted, similar to in C, what we have in C. That's the difference between stack and heap. So in this case, we had a local variable, the cat here. Okay, let's see a bit more promising or a bit more better example, which is a pretty good use case, I would say. And I think you kind of use something like that in your assignments. We have a playlist class here with a vector of song pointers. Okay, let's suppose we know that there is a different class of songs. Yeah, a song has some properties, maybe a title, a producer, whatever, a length, and so on. So we have here a vector of song pointers, and we store it in the variable songs. And then we have a public method called addSong, which takes a title, and this title is calling here the constructor of the song playlist, or of the song class. So the song class has one constructor which takes a string, which is the title, and this is created on the heap. We store that here in a new variable called new song, and then we push it into our vector. So we just added one more song to our vector. That's, let's say, a basic use case for vectors. This addSong method is a basic use case you will implement a lot, I think. So just creating something on the heap and then pushing it into a vector where we have a collection of pointers to the heap.
Then we can do something with these songs once they're stored in the vector. Maybe we can play the songs and do something. And at some time, we don't want to listen to the songs anymore. We want to get rid of them. And we have to do something when we want to get rid of them. So we have this destructor now here in our class, and we have to make sure whenever the playlist is deleted or goes out of scope, depends on if it is on the stack or on the heap. So whenever this destructor of playlist is called, we have to make sure that also all the objects that are stored on the heap, so in our case all the songs in our vector, are deleted as well. So we have to call the destructor of the song class by writing delete song. Otherwise, this would stay on the heap
Yeah.
and
Yeah, what
remain
happens?
there.
What happens if we don't do it in the destructor here? So what happens if we don't have this for loop in the destructor and not deleting the songs? What's the consequence if the program ends? Yeah, memory leaks. Yeah, so we are again using the heap, and whenever we're using the heap, we have to free, or in this case, delete the memory from the heap whenever we don't want to use it anymore. So I would assume when our playlist gets deleted, our program will end. Yeah. So we don't need it anymore. And then, of course, all our songs in our playlist should also be deleted. Otherwise, I have memory leaks. And that's a very, very good example when to use the destructor. So whenever you're using something with the heap inside your class, most likely you will delete it in the destructor. So whenever this object is destroyed, you have to remove all the things you have on the heap inside of this class.
Yeah, it's a very usual scenario.
Yeah. Okay, so when will this object be destroyed? It depends on the type, of course. As we said, the destructor is called when the object goes out of scope, when it's not on the heap. It's on the stack, for example. Yeah. Then also when it's on the stack and the memory is freed, then the object gets also destroyed. Of course, when the program ends, so also then static and global variables are destroyed, and the destructor of them is called. And the third one is when a thread ends, which we will not discuss further here. Everybody who is doing higher courses will know what it is. You will come to that in the next semester, what a thread is. Any questions to dynamic memory, destructor, use cases, whatever? Cool. I assume that there are many questions, but it's okay. As we did before, we will also have this Q&A session or this QA possibility after the lecture for the next few days open. So if you're looking the recording or sitting here, you can also ask questions there, and we will answer the questions then next time. Okay, we have two more small things left.
Yeah, exactly. Two more small things and one.
Look out for the next time.
Exactly. So, if you've done Introduction to Structured Programming, you might already notice that there can be multiple files that you use. So, I think it was in the second assignment where we had an additional file. For example, you can also have a header file and a source file, and the same applies also to C++. It's quite usual, you will also do this in the assignments, to split up your code into HPP files, into header files, and into CPP files, so into the files where you actually implement all the stuff. For example, we could have a header file, OOP1 math, where we declare two functions, very basic, just an add and a subtract. So we only have the declarations here without the actual implementation, because this will then happen in our definition, so the implementations in the CPP file. What we have to do is, and we already used to include, is that we have to include the OOP math header file. So we just specify name of the file .hpp, and once we have done that, we can then add the definitions of the functions that we have here, so we can actually implement our add and subtract function and still have the separation between the declarations and the definitions in two different files. quite useful, quite common in C++, also when you're working with classes, and you will do this a lot.
So for every class, basically we have two files, one header file, one HPP file, and one implementation file with the CPP file.
Exactly, yeah. So this declaration here then maps to the definition in the CPP file, and the same for the second function, for the subtract function. This then maps to this definition or the actual implementation of this function.
Let's have a look how it looks with classes. Maybe it's a bit more practical.
Yeah. So we have our, again, pet class here in our HPP file. We only declare our private members and the declarations of the public methods. So there's no actual implementation in here. Because this will then happen in our CPP file, again, we have to include the pet.hpp, so the name of this header file, and then we can actually define our, for example, constructor here, so the default constructor, but also another constructor that we have declared here. Any function, of course, the signature of the function must match, so it has to be of the return type void, and the method itself has to be const. And yeah, the same also for the destructor. We can have a specific implementation then in our CPP file.
Okay, one question. In the CPP file, why do I need always this pet double column before? That's
a very good question, and similar to the static, for example, that we've used, we need to define the namespace, or actually the scope of these methods, or of the constructors here, the method make noise and the destructor. So we have to specify that all of these elements are inside of the class pet, and we have to use the class name and scope resolution operator, and only then we can actually define the elements, so the destructors, constructors, and methods.
So on the left side here, we are already inside the class, so we don't need it. Here on the right side, we are kind of outside of the pet class, and to go inside the class, we have to use this namespace operator and pet double column to go inside of the class and to access the public elements.
What actually happens here in this line, when we include the HPP file, is that all of this here is, let's say, copied here instead of the include. And this means we now have the whole class definition with all its declarations in the CPP file, but we're still here when we come to the definitions outside of this class. And as you said, we have to use the class name and scope resolution operator to actually define elements of this class.
One more thing to add. This is when you write big classes. Yeah, so huge classes, or not huge classes, but classes with a lot of implementation. If you have a very, very small class, also for the homework, you can also write the implementation directly inside of the class. Yeah, so it works. But if you have a class like 500 lines of code, which is pretty large, then you definitely should move it out to a CPP file. So if you have just a one-liner, getter, setter, whatever, it's totally fine to declare it inside of the class only. But when it gets bigger, you should move it out to a CPP file. Any questions to header files or whatever? I think it's, again, a bit tricky in the beginning, but when you declare a few classes, you will get used to it. It's, again, just practicing. Any questions? Cool. Header guards.
Yeah, they are somehow related to multiple files, or actually to header files in C++. So we have seen that we can include some other header files. For example, here in our OOP1 nav header file, we now want to include another header file called OOP1 pi. Yeah, we have still the same functions, add and subtract. But what if we now have the header file OOP1 pi, which includes OOP1 math? That's quite, unfortunate. So this would mean this include here will copy all of the contents here. But this include here is also copied. And this
Ends in an infinite loop, maybe?
Exactly, this will never stop. So one header file will include the other one, while the other one will include the first one. So this would not work, and also the compiler will not allow this. So whenever we have one file that includes another header file, and this header file includes the first header file, or can be multiple files in a chain that somehow lead to a loop in the includes, we have to use header guards. So let's take a look. Here we have our main CPP. When we try to compile this now, the compiler will say, no, we have a redefinition and so on, and we already see too many errors emitted, and the compiler will stop now. Doesn't make sense to do any further work.
It's always a good idea if you have a lot of compiler warnings to scroll up to the first one.
Yeah.
First one is most likely the most important one. And if you read something like redefinition, it means that it's already declared somewhere. So it's kind of trying to include it from time to time. So yeah, that's the problem here. It also says here, okay, yeah, that looks interesting.
Yeah, that's quite helpful. So yeah, trying to include from one file, then again the other file, then again the first file and the other file, and so on. And yeah, this will not work, but there is a solution for this if we have a circular includes, and we can solve this using header guards. So the syntax is maybe the first look a bit weird, but absolutely makes sense. So this means if not defined OOP1 nav underline HPP, actually you can name this whatever you like, but it's quite common to use the same name as the file name. Then we define OOP1 nav underline HPP. Then we have this include here, and then we have the end if. And we do a similar thing here in our other header file. So again, we have the if not defined, then OOP1 pi HPP. We define it, and we end this. What this now prevents is that whenever we define OOP1 nav HPP, it is not defined twice because we have this if not defined, and this will only include OOP1 pi HPP once. Whenever the code, or whenever we try to copy the code from OOP1 pi HPP once more, we will see, okay, this is already defined. We don't need this anymore.
Yeah, so and it jumps basically over it.
It skips this part, yeah. And the same now also for the OOP1 pi header file. Whenever this is already included in this OOP1 pi, it just skips this part. And in this way, we can now prevent this infinite loop. We know, again, confusing, but very helpful, especially if you have a lot of different includes in the different header files. Yes, there's a question.
Do I have to write it if not defined above the define, or does it not matter?
Yeah, that's a very good question. Does the if not defined have to be above of the define? and yes, it has to be above, because otherwise we would have to define first and then if not defined. So you can imagine this like an if block in C or C++, for example. So this is the body, let's call it like this, of this if block, and this is the condition here. So it has to be in this order. All right. Then let's continue with inheritance, which is an outlook for the upcoming at least 2 lectures.
Yeah, so this multiple files and header files, at least in my opinion, was a bit boring.
Yeah.
It was just two things you need for implementation.
And I think this will be covered way deeper than in the practicals.
Yeah.
So
Yeah.
there we will also show some examples
Yeah.
on how to apply, for example, header guards. But now, again, the interesting part.
Yeah, so we are now working again with classes, and we go even further, try to combine classes, let's call it like this.
Again, we have our animals. I don't know if we should call them pets, but I think animals is more
Maybe
suitable
the
here.
fish and the turtle, but I doubt that anyone has a lion. Yeah, maybe.
Maybe.
Maybe there's
Who
some
knows?
people have a lion as pet.
Yeah, so what are some characteristics of all these animals? We have some attributes, so all of these animals will probably have a name, and I'm pretty sure that all of them will have an age. So on the one hand, we have attributes, but we also have a behavior. So all of these animals have a specific behavior, but it differs. What they all do is they run, slower or faster, they eat, and they sleep. So this applies
Not really to all, but to the lion.
to the lion.
Yeah.
Yeah. Now the fish, okay, it obviously cannot run. It can somehow move, but fishes usually swim
Yeah,
most of the time. And
eat, yeah.
of course, they will also need to eat something.
And I have no idea if fishes can sleep. I think it depending on the fish.
Maybe, but
Yeah.
let's say they just swim and eat.
Yeah.
And what behavior does a turtle have? It moves, okay, it doesn't run.
Cannot run, yeah.
And yeah, turtles usually also eat something. So we can see we have attributes that are the same, and we have some behavior that is the same. Not all of the behavior is the same, but we can see all of the animals eat, for example. However, the turtle moves, it doesn't run, it doesn't swim. Maybe it could swim. The fish swims, and the lion runs and sleeps. So we can see some common attributes and behavior. But before we actually come to inheritance, we will now show or write our animals as classes. So we have the class lion with the attributes name, age, and these 3 methods here. So the behavior is run, eat, sleep. Also the same for fish. It's the same attributes, but different behavior, only the swim and eat method. And the turtle, which again has the same attributes, but different behavior. It moves and it eats. So we have, in this case, 3 classes, and we have a lot of similarities, which would lead to duplicated code. We have attributes that are the same for all of the 3 types of animals, and we also have a bit of the behaviors of some methods, which is the same for all these 3 animals. So what could we do? We could now first take a look, okay, which is the same for every animal, and we can then move all of the same attributes and same behavior in one class that could be called animals. So how would this now look like in C++. We create an additional class, a base class called animal. We will add here everything that is the same for all of our different animals that we have. So what is the same for the lion, for the fish, and the turtle? And in our case, this is the name and the age, and one method, namely the eat method. So we have extracted all the same attributes and same behavior into one base class. Still, we can have the classes for lion, for the fish, and for the turtle.
Yeah, I think that's wrong here. It should be, of course, the fish is a subclass and the turtle is a subclass.
Exactly.
Copy-paste error.
Yeah. And we don't actually need these attributes here anymore in any of the subclasses. And we also don't need the eat method in any of the subclasses anymore. So we can just remove them since we have them in our base class. And once we have defined them in our base class, we can then just use them in the derived classes, so in the inherited classes. That's quite nice. It leads to less code, less duplicated code for especially. And still, this would work. So we could now, in our class lion, for example, use these attributes here, the same also in the fish and the turtle classes. And we can also use this method here, so the eat method, in our lion class, in our fish class, and in our turtle class, without having to define this method directly in there. And regarding the syntax, this is how we define a subclass of a base class. So base class looks the same as we have already seen in many examples today. But the subclasses use this colon here. And for the moment, it's totally fine to just use public and then the name of the base class. And this is how we inherit the members and also the methods of a base class. So if we now remove all the code that is not necessary anymore, we don't have any members here in our classes lion, fish, and turtle anymore, but only the methods that are dependent on the type of animal. So the lion has now the run and sleep method, the fish has the swim method, and the turtle has the move method. But still, all of these animals have a name and an age, and also one method called eat. Probably not that easy to understand, especially since we've covered a lot of content today. But this is one, again, very important concept of object-oriented programming, that we can now have a base class which has a basic set of attributes and a set of methods and multiple subclasses. So we can have, again, an arbitrary number of subclasses that inherit all of these attributes and the methods without stating them explicitly in the class definition.
And that's why it's called inheritance, or in German it's Vererbung. So we kind of have the one thing on top, and then we have the children. Yep. Kind of a binary tree, but not really. I think we should introduce the terminology at the end, and we will do a lot about inheritance next week. So it's just a teaser. Yeah, there's a question. Where? Here? that's why we don't want to discuss it in detail. Yes, you are correct, but we will come to that next week. We discussed that, but we now think that currently you don't know what's needed here, but you're correct. Yeah, you would need another keyword here that it work. But yeah, I think that's just a teaser for next week, that you have the basic understanding of inheritance and what it is. We have a base class. So we have a lion, which is a subclass of the derived class of animal. So all the classes, animal is the base class, yeah. Lion and turtle and fish are the derived classes. And you use inheritance if you have really, so if you can say that a lion, a fish, and a turtle is an animal. That's the most important thing. So inheritance describes is a relationship. A lion is an animal. A fish is an animal. It does not work when it's similar or when it contains something. So a car, or let's say a wheel is part of a car, but it is not a car, obviously. So it's just a part of the car. So here inheritance would not work.
But also in this case, if we have it the other way around, so not every animal is a lion, or not every animal is a fish or a turtle. So it only works the one way. Every lion, every fish, every turtle is an animal.
Yeah. Yeah.
All right. Now, this is already the conclusion of today's double lecture. So we have now introduced classes, which are a very fundamental concept in object-oriented programming, because they group members or attributes and also the behaviors or the methods into one element, which is called class. And we also learned about constructors to create objects, but also destructors to clean up resources. We've also talked about the copy constructor, which is called sometimes not that obvious, but still very important. For example, when assigning an existing object to a newly created object. And we also saw how dynamic memory is managed in C++, so we don't have to use malloc and free anymore, but we can now use new and delete. But still, the principle of dynamic memory is the same in C++.
Okay, so we discussed a lot, and just to mention once again for everybody here, but also in the recording, if you have questions, this Q&A session here is open for you to ask the questions, so just log in and ask your questions. It's open until next week, Wednesday, I think, and then we will collect the questions and answer them next week. So that's our new way to maybe get you more engaged and ask questions anonymously. Okay, thanks for being here. It was a pleasure. It was a lot today.
Yep.
See you next week.
See you. Bye.